It is very common for you to be asked to turn a repeating decimal into a fraction, and there are many strategies to do this, but my personal favorite is to use a little bit of algebra. So if I'm asked here what fraction can be represented by the repeating decimal 0.28888 with the 8 repeating, also could be written like this with just a bar over the 8, I would first call that number x. So I know x equals 0.28888, etc. Okay? Then what I'm going to do is I'm going to multiply this x by powers of 10 by moving the decimal point. So I know that 10x then equals the decimal slid once, 2.8888 repeating, etc. Okay? What my goal is to do is to be able to get everything after the decimal point to look the same in two expressions. So I'm going to try doing 100x. I would move the decimal over twice. And 100x equals 28.888 repeating, etc. So now what you're going to notice is that I have here 10x and 100x, and after the decimal point, all they have is 8s. So I'm going to perform a little bit of algebra, and I'm going to subtract these two quantities. So I'm going to have 100x is 28.888, etc. And 10x is 2.88, etc. When I subtract these two, and I do the same thing to both sides, these are equivalent, I'm going to say 100x minus 10x is 90x, and that's equivalent to 28.888 minus 2.888, which notice these 0.8 repeatings cancel out, so we can just do 28 minus 2 is 26. That means that 90x equals 26. So if I'm trying to figure out what x is as a fraction, what I'm going to do is divide both sides by 90 here. And then I get the equation x equals 26/90ths. Of course I want to reduce that. They're both divisible by 2, so x equals 13/45ths. So remember, x was this repeating decimal, 0.2888. X is also 13/45ths, so those must be equivalent. So 0.28 repeating must equal 13/45ths. It's good to practice this with a lot of different numbers, and you can double check on a calculator, do 13 divided by 45, and make sure it really does equal 0.2888 repeating.